Hi everyone, this is your first video in this second section in Unit 2. So in this section, I'm going to talk about describing and comparing distributions. We're also going to talk about the 5-number summary and box plots. I told you in the last section that I would get more into box plots and how we use them, how we make them, things like that in this section. And then I'm also going to tell you a little bit about how the standard deviation formula came about. It's this kind of complex formula, so it helps sometimes to hear or see what each component of that formula does to get a better understanding of how to use it. So this video is on describing and comparing distributions. This is a very, very common thing that is asked on a lot of AP Stats FRQ type questions, especially. Um, it's often incorporated with other aspects of the course, right? Being able to describe data, right? Being given a visual representation of data and then being able to describe that in words is one of the major skills that you want to be able to, that you want to know how to do by the end of taking a statistics course, right? Because remember, this class is about a search for the truth. So if we're given a visual representation of that truth, then we have to be able to describe that and use that description to better understand the data that we're looking at, so that we can make inferences and do all of that kind of fun stuff. So with that, let's talk about describing quantitative data. So there are lots of acronyms that stats teachers like to use when they are teaching how to describe quantitative data, but I like this one the best because I think it's the most memorable. So whenever you are describing quantitative data, you have to talk about 4 things, right? And those 4 things can be summed up in this one phrase, which is cuss and BS, right? So this is what you want to remember to do. These are the 4 things that you have to do when you're describing a distribution or when you're comparing distributions. So the C stands for center. Okay, so your center will be either the mean or the median, whichever makes the most sense for that data set, or whichever is given to you, right, or easiest to calculate. You don't have to describe both, right? You just have to choose at least one, mean or median. U stands for the unusual. Okay, and what I mean by the unusual is any gaps and outliers that you see. Okay, so for this, you do have to describe both. If you see a gap in the distribution, right, include that, and then usually with gaps, that means that there may be some possible outliers. Okay. S, the first S stands for shape. Okay, so you're just describing in general what the distribution looks like. So there's lots of different terms that we can use to describe distributions. So there's uniform distributions, approximately normal, which is like your typical bell-shaped curve, bimodal, which almost looks like humps on a camel, because it has two peaks, two modes. Okay, and then another common shape is skewed, either left or right. And I'm going to talk about how you know which direction you're skewed. So those are your typical shapes that you're dealing with. More often than not, the most common ones that you will see are approximately normal and then skewed left or right. All right, and then your last S stands for spread. Okay, so spread, you're either going to talk about IQR, which is interquartile range, IQR. I should put that in brackets so we don't have parentheses inside parentheses. Okay, so abbreviated IQR / range. Okay, so one or the other. Okay, if you have the ability to do IQR, it's more accurate. So use that whenever you can. But if you don't have the ability to calculate an IQR, then range is okay. Right, so IQR or range or standard deviation. Okay, so just like mean or median, um, you don't have to describe both, just one or the other, right? So pick either IQR range or standard deviation, whichever makes the most sense for that data set. Okay, and then BS stands for be specific. Okay, so you never want to just say the shape is approximately normal. You would want to provide some context. So the shape of the distribution of spices in our spice cabinets is is skewed to the left, for example. Okay, so include context whenever possible. And this is AP stats, so context will almost always be possible, right? They're going to put most problems in some type of real world study or context, right? So include context whenever possible. Okay, so those are your 4 things that you have to talk about when you are describing quantitative data. Okay, so I'm going to tell you a little bit about skewed distributions. So we've talked about this a little bit before in some of our lessons, but I want to give you an exact definition and give you some pictures to look at. Okay, so skewed distributions are distributions where you have a lot of data on one side and then a little bit of data on the other side of your plot. Okay, so skew almost goes in the opposite direction than you would think, right? Because skew, if your data is skewed, it's because there's a lot of data on one side. So you would think that if a lot of the data is on the right, then that we would say that that data is skewed right, but that's not correct. The skew always goes in the direction of the tail. So you want to think of skew like you're holding a piece of taffy, right, and pulling one end in either direction, right? So a left skew is when you have a long tail on the left hand side. So that's this drawing right here. Okay, left skew is also sometimes called negative skew, but usually you can just use left and right. Okay, so your data will look like it's being pulled to the left. Okay, and then a right skew is the exact opposite. Okay, so it's sometimes called positive skew, but most of the time you'll just hear it called right skew. So a distribution is skewed to the right if the tail is being pulled to the right. Okay, so it's all about the tail when you're talking about skewed distributions. Okay, so when you are comparing distributions, you're still talking about those 4 things: center, unusual, shape, and spread. But you just have to use comparative language. Okay, that is a must. Okay, you must use comparative language. Okay, meaning the mean of distribution A is larger than the mean of distribution B, or the shape of distribution A is approximately normal, while the shape of distribution B is bimodal. Okay, or the IQR of distribution A is equal to 12, which is less than the IQR of distribution B, which is 15. Okay, so I'm going to show you quickly a full example, which is if you're in the student notes, you'll have to scroll all the way down to the last page to see this full comparing distributions example. So there's 2 distributions there, distribution A and distribution B. Okay, now this is a histogram, right, which we talked about in the last section. So one of the pros of histograms is that it's very easy to see the shape that you are dealing with, but other things are more difficult to find. So the center, for example, is difficult to get an exact value for. Same thing for spread. It's difficult to get an exact value for spread because you really only have a range. within each bin. Like you don't know where the data point lies within each bin. So shape and not shape, sorry, the center and spread can be difficult to determine in a histogram, but it is possible. So I'm going to show you how to do that quickly before I talk about how this is compared. So if you look at distribution A, okay, in this histogram, I told you that there's a total of 25 entries, meaning that the center is the middle entry, right, which is the 13th entry. I don't know why I wrote 12th and 13th, okay? So the 13th entry, the 13th number from the bottom will be your center, your median, okay? So you can use a histogram and use the y-axis of the histogram, which is called the frequency, right? If you remember that from the last section, to figure out how many data points are within each bin, which is what these numbers are inside of each bin, right? So I went and looked and said, okay, so from 20 to 30, right? There's only one entry, right? One entry here, 2, 3. Okay, so this one right here is like the first entry, right? It's the lowest entry. Then this data point is the second, right? Then you have the third and fourth here, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. So the 13th entry is in this bin somewhere. So it's somewhere between 70 and 80. We don't know exactly where, but we can at least make a guess, okay? So that's how you can figure out and write about center using a histogram. So here's my comparative distribution example. Okay, so for center, right, and notice that I indicated which center I used. I used median in this case because I really can't figure out mean from this one with just the picture. If I had some summary statistics in a table, then I might be able to figure this out, but I really can't figure out the mean, the average here. So I have to use median. Okay, so I said the center, which is the median of distribution A, is higher than that of distribution B. Okay, so there's my comparative language, right? I use my comparative language, and then I just noted what the centers were for each. So distribution A's median is between approximately 70, or between, you could say between 70 and 80. In distribution B, if I do the same thing, right, it has to be the 13th entry. So here's the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th. So the 13th entry has to be in this bin. So somewhere between 30 and 40, right? So distribution A's median is approximately 70, or you could say between 70 and 80. And distribution B's is between 30 and 40. Okay, so note that I stated what the actual center was, and then I compared the centers, right? So you have to state the center, or what, whatever it is you're talking about at that step, right? So center, the shape, spread, number of outliers, etc. Okay, so state them, okay, and then, right, so state them and then compare, right? What's higher, what's lower, etc. Okay, so for U is the unusual. So I'm looking at my distributions. A doesn't look like it has any outliers or gaps. So that's what I wrote. Distribution A has no outliers or gaps. Distribution B does have a gap from 60 to 70, right? So again, so I stated where the gap was, right? I stated exactly where it was, and I'm comparing them by saying distribution A has no gaps or outliers, but distribution B has one gap. And I said possible outliers here because I don't know if these values up here, these more extreme values, I don't know for sure if they're outliers. Okay. I'm going to show you exactly how to calculate outliers in the next video. on the 5-number summary. Okay. All right, then my third thing that I need to talk about is shape. Okay, so here, if I'm looking at distribution A, that is definitely skewed to the left. I can draw a little curve over the distribution and see that the tail is being pulled to the left. So I said distribution A is skewed left, and then your comparative language is this word while. Okay, so while distribution B is, and I would say distribution B is approximately symmetric, or you could have maybe said skewed to the right. Um, Either really would have been okay with this data set. Okay. All right. And then last bit here is spread. So with spread, you have to talk about, with a histogram, you really have to talk about range. You can't really talk about standard deviation or IQR unless they give it to you. Okay, but range is something that I can pick out, right? In distribution A, for example, I know my max number has to be 90, and my min number, right, can't be any lower than 20. Okay, so here the range of distribution A is, and I really should have put an approximately, is approximately 70. But the range of distribution B is approximately 100, right? So I stated what the ranges were, and then I'm using my comparative language, right? So I said the range of distribution B is greater than the range of distribution A. Right, so that's how you compare distributions. You don't necessarily have to write a whole bunch as long as you state what you're talking about, like, which statistic are you talking about? Are you talking about gaps? Are you talking about shape? Are you talking about standard deviation? Are you talking about median? Like, what are you talking about? And then compare those, right? So give me just a sec, y'all. I have to clear my screen off and move the notes on the right hand side. So I will see you back here in just a moment to talk about mean versus median. All right, y'all. So let's talk about mean and median. Okay, so mean and median are your two most common measures of center, right? And you've likely heard these terms before, right? So mean is just our fancy statistical term for average, right? It literally just means average. But the important thing to note about the mean is that it is heavily or easily influenced by outliers. Okay, and that's because of the way that it's calculated, right? So, in order to calculate the mean, you add all of the observations together and then divide by the total number of observations that you have, right? So if you have, say, a data set with a lot of small numbers and then one really large outlier, then you're going to end up with a mean that is being pulled towards that outlier. Okay, so when you're talking about center for skewed distributions, and I'm going to zoom in a little bit on our skewed distributions. From another part of this video, right? The couple minutes ago in this video. So the mean, which is depicted in yellow here on the right-hand side of your screen, the mean always is pulled towards the skew because it's influenced by the outliers. It's going to go in the direction of the outliers, right? So this is a very common type of multiple choice question for AP Stats. They love to ask questions like this, where they ask you, they'll give you a diagram like these without the labels of mean, median, and mode, and ask you to label which of these lines is the mean, which is the median, and which is the mode. So remember, mode is always the highest point, right? It's the peak. The median will divide the area of the distribution in half. So it's like the 50% mark. And then the mean is like the balance point of the distribution. So it's always going to be pulled towards the skew. If there's no skew, the mean and the median will be the same. But if there is skew, the mean is always going to be pulled towards the skew. So in a left skewed graph, the mean is going to be less than the median, In a right skewed graph, the mean is going to be greater than the median, and that is always going to be true. Okay, that will always be true. Okay, well, I gotta zoom out a little bit here. Okay, so that's mean, and then median is quite literally the midpoint of your data. Okay? Like it's literally the middle point, right? So the best thing to do to figure out the median is to list all of your data in order from smallest to largest, and then figure out where the middle value is. Okay, there's one important thing I want to make sure that I point out to you, okay, which is that some distributions will have an even number of observations and others will have an odd number of observations, okay? So if you have an odd number of observations, the median is going to be obviously that middle point, right? Whatever that middle value is, okay? But if the number of observations is even, what you have to do to find the median is average the two observations in the center to figure out where the actual center is, okay? Now, I'm going to do an example here for you about how to find the mean and median of this data set that I gave you here. This data set is commute time for 20 random people. And I'm actually going to pull this over because I'm going to do a little bit more of my writing on your actual notes page here so we can see this a little better. So I already went ahead and listed the values that they gave me because they're completely out of order right here. You'll notice that they're completely out of order, which doesn't really help me. So what I need to do is list them in order. Now, you don't always have to do this by hand. Okay, you have a calculator for the entirety of the AP Stats test. They will never take the calculator away from you. So what that means is that you can use the calculator to your advantage, right? A teacher that used to work at Valley who used to teach calculus would say, let the calculator do the calculator work, meaning let the calculator do all of the menial stuff, like listing all of your data points in order, for example. Okay, because it takes the calculator next to no time to do that, and it'll take you probably longer than it will take the calculator. So in your Canvas modules, in the very first module, the Welcome to Statistics module, there's a page on there that's called Formula Sheets and Charts. I'm pretty sure that's what it's called, like Formula Sheets and Charts. So on there, in that page, there's a document of calculator how-tos. So a lot of you picked up and have TI Inspire calculators now at your disposal. So it'll show you how to enter data into a spreadsheet and then how to organize that data, how to calculate stuff with that data, have the calculator do a lot of that work for you. Okay, so for the cases of this video though, I already went ahead and listed these, okay, from smallest to largest. Notice that there are some repeats. Right? There are some repeat numbers. That's fine. That will happen a lot of times. So what you can do quite literally is do the cross off method, right? And do like, okay, I have 1, 2, 3, 4, 5, 6. Maybe I'm going to cross off 7 on the left, which means I need to cross off 7 on the right. 1, 2, 3, 4, 5, 6, 7. Okay, and then keep crossing off until you find out where the middle is, which is right here. Another way you can think about this is I know there's 20 random workers. So that means I can take that number 20 and cut it in half, and I get 10. So what that means is that my 10th and 11th observations will be like the middle there. Okay, so if I want to calculate and find the mean and the median, so the median here is the average of these two middle observations to figure out where the true middle is. So the median is 20 plus 25 divided by 2, which is 22.5. Okay, and then the mean to figure out the mean, I just added all the values. So I had 5 plus 10 plus, then I'm going to put dot, 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 right? And all the way to the last observation, 85. I've added all of those up and I'm dividing by 20 because that's the number of observations that I have. And really, y'all, I didn't actually calculate this. I had my calculator do it for me. I entered all of the data and then said, calculate mean, and it did it for me. Super awesome, right? So you don't have to take the time to actually do the calculation. If you show the people that are grading the exam that you know how to do this by writing out parts of the formula like I did here with the 5 plus 10 plus dot, 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 right? And then just put the number, that's enough, okay? So here, I get that my mean is 30.75. So if you have your median and your mean, you can compare them and say the median is much less than the mean. So what that probably means is that my distribution is skewed to the right, okay, because the mean would be like here, okay, and then the median might be here, for example, okay? So since the mean is greater than the median, this distribution is skewed right, which is not a part of this question necessarily, but something that I just wanted to note for you all. All right, so that is the end of this video, the end of this section or this part of this section. In the next video, I'm going to talk to you about box plots, IQR, 5-number summary, all that fun stuff. So I'll see you all in the next video. Bye, everybody.